Good morning. First of all, recall the formula of sin a plus b, sin a minus b, cos a plus b, cos a minus b. So first formula, sin into bracket a plus b is equal to sin a into cos b plus cos a into sin b. Second one, sin into bracket a minus b is equal to same formula, in between minus sign we can written. So sin a into cos b minus cos a into sin b. Next, cos into bracket a plus b is equal to cos a into cos b. Here in between plus sign is present, so here we can write minus sign. So minus sin a into sin b, and cos into bracket a minus b is equal to cos a into cos b. In here minus sign is present, so here we can write plus sign. So plus sin a into sin b. Now related to this formula, discuss one example. Prove that tan a plus tan b upon tan a minus tan b is equal to sin into bracket a plus b upon sin into bracket a minus b. So first of all, start LHS side. Tan a plus tan b upon tan a minus tan b. Now we know that tan theta is equal to sin theta upon cos theta. So tan a, in place of written here sin a upon cos a, same here tan b is present, so we can written sin b upon cos b. In denominator term, same formula we can apply here. Tan a, in place of written sin a upon cos a, minus tan b, in place of written sin b upon cos b. Now after take LCM in numerator term and same term LCM in denominator term. So in numerator term and denominator term LCM same. So our LCM is cos a into cos b. So cos b here not present, so multiply sin a into cos b. So our first we can written our LCM is cos a into cos b. Now sin a into cos b plus cos a into sin b upon, same way in denominator term LCM same, so cos a into cos b, our LCM. So now here we can written sin a into cos b minus cos a into sin b. Now LCM same, in denominator term, so cancel out this term. So now remaining term is here sin A into cos B plus cos A into sin B, and we know that sin A into cos B plus cos A into sin B, that means here we can written sin A plus B upon same way in denominator remaining term is sin A into cos B minus cos A into sin B, and this one is also formula of sin A minus B. So here we can written sin into bracket A minus B. So our proof is our RHS side is sin A plus B upon sin A minus B. So here we get sin A plus B upon sin A minus B is equal to RHS. Now today we are going to discuss the formula of tan A plus B, tan A minus B, cot A plus B, cot A minus B. So first of all discuss formula of tan A plus B. So our first formula tan into bracket A plus B. So tan A plus tan B upon 1 minus tan A into tan B. So tan A plus B is equal to formula tan A plus tan B upon, in numerator plus sign is present, so in denominator change the sign, so 1 minus tan A into tan B. Second formula, plus in place of minus sign is present, so how can be written? So tan A minus B is equal to tan A minus tan B upon 1 plus, in numerator minus sign is present, so denominator we can written plus sign, so 1 plus tan A into tan B. Third formula, cot into bracket A plus B, so is equal to cot A into cot B minus 1 upon denominator term cot B plus cot A. And fourth formula, plus in place of, here we can written minus sign, so cot into bracket A minus B is equal to cot A into cot B plus 1 upon, in denominator term we can written cot B minus cot A. So now related to all this formula, discuss some example. So our first example, first of all find out the value of tan 15 degree. So our first question, find the value of tan 15 degree. Now the value of tan 15 degree is not given in our trigonometry table. So first of all we can convert tan 15 degree, in place of we can written here tan 45 degree minus 30 degree, because both the value of tan 45 and tan 30 value is present in trigonometry table, and here 15 degree is present, so 45 minus 13, that means 15 degree. Now after here apply the identity tan A minus B, so is equal to tan A minus B, that means tan A minus tan B means tan 45 degree minus tan 30 degree upon 1 plus tan 45 degree into tan 30 degree. So here apply the identity 10a minus b is equal to 10a minus 10b upon 1 plus 10a into 10b. Now all this value present in trigonometry table. So tan 45 in place of written 1 minus tan 30 degree in place of written 1 upon under root 3 upon 1 plus tan 45, that means 1, and tan 30 degree in place of, again we can written 1 upon root 3. Now after take LCM, so under root 3 our LCM term, numerator and denominator LCM same, so we can written here under root 3 minus 1 upon, same way in denominator term, under root 3 plus 1. After under root 3 cancel out, so is equal to remaining term under root 3 minus 1 upon under root 3 plus 1. Now after multiply conjugate of this denominator term, so under root 3 minus 1 upon under root 3 plus 1, multiply conjugate of denominator term, so here we can written under root 3 minus 1 upon under root 3 minus 1. Now here both these terms same, under root 3 minus 1, another bracket under root 3 minus 1, so here we can written under root 3 minus 1 whole square upon, in denominator term, under root 3 plus 1 under root 3 minus 1, so here apply the identity a plus b, a minus b, that means under root 3 whole square minus 1 whole square. So is equal to, here in numerator term we can apply the identity, apply the formula a minus b whole square, that means under root 3 whole square minus 2 under root 3 into bracket 1 plus 1 whole square upon, in denominator term, under root 3 square, that means 3 minus 1, same way here square and under root form is present, so cancel out this term, so remaining term 3 minus 2 under root 3 plus 1 upon, in denominator term 3 minus 1, that means 2. Now 3 plus 1 means 4 minus 2 under root 3 upon 2. Now 2 we can take common in numerator term. So remaining term 2 minus under root 3 upon 2. Now after 2 to cancel out here, so our final answer 2 minus under root 3. So here we get the value of tan 15 degree is equal to 2 minus under root 3. Next question. Tan into bracket pi by 4 plus x upon tan into bracket pi by 4 minus x is equal to, prove that 1 plus tan x upon 1 minus tan x whole square. So again start from LHS side. So in LHS side, first of all tan pi by 4 plus x upon tan pi by 4 minus x. So here apply the identity tan pi by 4 plus tan x upon denominator term 1 minus tan pi by 4 into tan x. Same way in denominator term apply the identity tan a minus b, that means tan pi by 4 minus 10x upon 1 plus 10 pi by 4 into 10x. Now, using by trigonometry table, we know that the value of 10 pi by 4 is 1. So here 10 pi by 4, in place of we can written 1 plus 10x upon in denominator term 1 minus the value of 10 pi by 4, 1 into 10x, means 1 into 10x means we can also written 10x. In denominator term also 1 minus 10x upon 1 plus 10 pi by 4, that means 1 into 10x. So is equal to 1 plus 10x upon 1 minus 10x. Now here in denominator term we can written in numerator term, so change the position. Here division form is present, so we can written in numerator. So in denominator term we can written in numerator, interchange the position of numerator and denominator. So this term we can written in numerator. So here change the position, so 1 plus 10x we can written in numerator and 1 minus 10x we can written in denominator. Now here 1 plus 10x into 1 plus 10x, that means 1 plus 10x whole square. Same way in denominator term 1 minus 10x, another bracket 1 minus 10x, that means here we can written 1 minus 10x whole square. And this term we can written in form of, we can also written in this way, 1 plus 10x upon 1 minus 10x whole square. So is equal to, we can written RHS side. So 10 into bracket pi by 4 plus x upon 10 pi by 4 minus x is equal to, we get this result. Now next question. So that ten 3x into 10 2x into 10x is equal to 10 3x minus 10 2x minus 10x. So first of all, 10 3x, in place of, here we can written 2x plus x, that means 3x is equal to, we can written 2x plus x. We can also written first we can also written x and after we can written 2x, we get same answer. In another way also we can written 2x is equal to 3x minus x, so again we get same answer. So here 3x is equal to, we can written 2x plus x. Now after apply 10 in both the side, so 10 3x is equal to 10 into bracket 2x plus x. Now after apply the identity 10a plus b, that means 10a plus 10b upon 1 minus 10a into 10b. So 10 here we can written 10 2x plus 10x upon 1 minus 10 2x into 10x. Here we can written 10 3x. Now after this denominator term multiply with 10 3x. So therefore Here we can written tan 3x into bracket this denominator term multiply tan 3x. So 1 minus tan 2x into tan x is equal to tan 2x plus tan x. Now tan 3x multiply in both this term. Here total 2 term is present. So tan 3x multiply both this term. So therefore tan 3x into 1, that means tan 3x, minus here written tan 3x into tan 2x into tan x is equal to tan 2x plus tan x. Therefore, now tan 2x and tan x we can written in opposite side, and all this term we can written in opposite side and change the sign. So now tan 2x plus tan x we can written in opposite side. So tan 3x minus tan 2x minus tan x is equal to this negative term, all this term we can written in opposite side. So we can written here tan 3x into tan 2x into tan x. So our proof is tan 3x minus tan 2x minus tan x is equal to, we get tan 3x into tan 2x into tan x. Next question. If 2 tan beta plus cot beta is equal to tan alpha, then prove that cot beta is equal to 2 tan alpha minus beta. So here in this question condition is present 2 tan beta plus cot beta is equal to tan alpha. So this condition is given, and using by this condition we can prove this result. So first of all start RHS side. So our RHS side 2 into bracket tan alpha minus beta. So here apply the identity. So is equal to 2 into bracket tan alpha minus tan beta upon 1 plus tan alpha into tan beta. Now in our question condition is given tan alpha is equal to 2 tan beta plus cot beta. So here tan alpha present in numerator and denominator. So in both this place we can substitute this value. So is equal to 2 into bracket tan alpha in place of written 2 tan beta plus cot beta minus bracket over minus tan beta. In denominator term also substitute this value. So 1 plus tan alpha in place of written 2 tan beta plus cot beta into tan beta. Now 2 tan beta minus tan beta, that means we can written here tan beta. So 2 into bracket tan beta plus cot beta. In denominator term here 1 plus 2 tan beta into tan beta, that means 2 tan square beta and tan beta into cot beta. So cot, here we can written cot beta into tan beta bracket over. But we know that one result tan beta into cot beta, that means 1. So this value we get 1. Tan beta into cot beta is equal to one result is present 1. So here we can apply tan beta into cot beta in place of 1. So is equal to 2 into bracket tan beta plus cot beta bracket over upon 1 plus 2 tan square beta plus 1. Now 1 plus 1, that means 2. So is equal to we can return 2 into bracket tan beta plus cot beta in place of, we can also return here tan beta upon, in denominator term 1 plus 1, that means 2 plus 2 tan square beta. Now in numerator term tan beta is LCM, so 2 into bracket tan beta, here we can written tan beta into tan beta, that means tan square beta plus 1 upon, in denominator term 2 we can take common, so 1 plus tan square beta. Now here 2 cancel out, so in numerator term 1 plus tan square beta, same way in denominator term 1 plus tan square beta, so again cancel out this term. So 1 plus tan square beta, 1 plus tan square beta also cancel out, so remaining term only 1 upon tan beta, and we know that 1 by tan beta, that means cot beta. So our proof is, our LHS side is cot beta, so here we can written LHS. Okay.